Okay, so this is again a review from grade 10. So we're going to start with defining some terminology here, and then we're going to move on to actually doing the work using these terminology. So like terms, they have variables that are identical in every way. So you're going to hear me say that word often, like terms. So when I say like terms, I mean they're terms that have the same letter and the same exponent on that letter. Okay? So let me give you an example. If I look at 4x and 10x, okay? We call these terms like terms because they have the same letters, x with the same exponent. Okay? Let's say if we have a, b, and 7a. Okay? These are also like terms because they include the same variables with the same exponent on top of them. That number in front does not matter. Okay? That's called the coefficient. Okay? So this is another terminology that you should know. It's called the coefficient of that term. Okay? Now, unlike terms, they don't have the same variable. Okay? So let's say 4x and 10x squared. These two terms are not like terms. They're not. Why? Because the exponent is different. You see, this one has an exponent of 1, this one has an exponent of 2. So that right away makes it as unlike terms. Okay? Another would be, let's say, if I have a and 3ab. Okay? These are also unlike terms because one has only a, the other one has ab. Are we okay with this so far?
Hold on. A, up here. All right, you can see it.
Okay? Now we will be talking a lot about this. It's called the distributive property. So the distributive property allows you to multiply a term outside the bracket by each term inside the bracket. So it's called the distributive property. So if you look at this right here, this sheet right here, right? If you have, let's say you have 3 and then bracket 2 tacos plus a Sprite and then close bracket, that means you're ordering 3 combos. Okay? So what you're going to end up with, you're going to end up with 6 tacos and 3 Sprite. And this is thanks to the distributive property. Because when I do 3 times 2 is 6, right? And then 3 times 1 is 3. Okay? We're going to be doing that a lot. We're going to be doing that distributive property a lot. We're going to be using it a lot of times, and you have to be aware of it. Okay? So, if I have, for example, 3, 2x plus 1, okay? I'm going to use my distributive property. So that means this 3 is going to multiply by this term, and it's also going to multiply by that term. So I'm going to end up with 6x plus 3. Now, are you guys okay with this distributive property? Okay, we're going to see it a lot, and then I'm going to refer to it every single time, so remember. Then we're going to move on to what we call a polynomial. Polynomial means, poly means multiple, okay? So a polynomial is a mathematical expression containing terms being added and or subtracted. So whenever you see something that looks like this, for example, like this, you're going to call that a polynomial. Things that are added and subtracted together. Okay? Now, there are some polynomials that have unique names for them. Okay? So a polynomial with two terms is called a binomial. A bi. Bi means two. Okay? So we call it a binomial because it only has two terms. So if you look at this right here, 6x plus 3, this is a binomial because it only has two terms that are added together. Right? Can you guess what a polynomial with three terms is called? Trinomial. Trinomial. Okay? So a trinomial is a polynomial with three terms. Okay? So a trinomial might look like this: 3x squared plus 5x plus 1. Right? So that is a trinomial. Are you guys okay?
Does it have to be two different types of?
Yes.
Okay.
Yes. It can be. So this is. So let's say if I have this, for example, I know what you're trying to ask. Right? I don't call this a trinomial because 3x squared and 2x squared are like terms, right? They are like terms. So I have to put them together, which means I have 3 of them and 2 of them, so that makes it 5 plus 1, right? So what do we call this? Binomial. Binomial, right? So that's why you have to be careful because before you give it the name, just in case you have like terms that can be put together.
So when you finish solving, that's when you bring it.
That's right. Okay? When you finish at the end and you put things together, that's when you can name it. Okay? Are you guys okay with naming so far? Okay. So what do we call each of these? So what do I call this? What do I call this? So what do I call each individual thing? A term. Okay? So a term is a number grouped with one or more variables. Okay? So if you see this one, 6x, we call this a term because it's a number which we call a coefficient, and a variable in this case is an x.
6 is a coefficient. Am I right?
Sorry?
6
6 is a coefficient. Yep. That's right. So let's say if I have y equals 6x, right? And I'm done. That's called a monomial. Monomial means 1. Okay? So you can see that I only have one term here, which is the 6x. So far we have 3 special names, and then if I have something else other than these 3 special things, we call it a polynomial. We don't bother with that anymore. Okay? So monomial means 1 term, binomial means 2, trinomials mean 3. Anything more than that, it's called a polynomial. Remember that monomial, trinomial, and binomial is also a polynomial, but they have a special name. Are we okay with this? Yes? Okay, excellent. Now, simplifying algebraic expression. Very, very, very important skill that everyone should know, learn, and don't forget. Okay? Because anything, no matter what you do, you're gonna have to use it. No matter what math strand you're working with, you're gonna have to use it. And it's basically simplifying. Making sure that, what you see how many terms I have here? I have like 6 terms, right? If I can put them together and make it shorter, why not? But there's rules for it. You can't just jump in and add all of them together because it's short. Okay? I can only add, what do we call them? Like terms. The only thing I can add together is called like terms. I can't add apple and oranges. I have to add apples together, oranges together. Okay? So, what I have here is I have 4x squared plus 6x minus 3 plus 4x minus 10x squared plus 6. Identify your like terms. So, do I have any like term to 4x squared?
Yeah.
What is it? Negative 5. Right? So you always take it with the sign in front of it. Okay? So I have 4x squared and I'm taking away 10x squared. What am I going to end up with? Negative 6 what?
X squared.
When you're doing this, you don't change your variable. Variable stays as is with its exponent. Now, do you have any like terms to 6x? 6 and 4. Which equals to? So plus 10x. So I have negative 6x squared plus 10x. And then I have negative 3 and plus 6, which gives me plus 3.
So the first one was 4x2 take away 10x?
That's right. 10x squared, right? 4x squared, take away 10x squared, gives me negative 6x squared. Are we okay with this? So you see, from a 6-term polynomial, I reduced it to what we call a triangle.
So then you did positive 6x take away what?
3.
Positive 6x take away 3?
Yeah, because we have negative 3, and you're adding 6 to it, right? So that gives you a positive.
And the 6 is the bigger number.
That's right, so it wins with a positive. Correct.
It becomes positive 3?
Yep. Okay, so you can always use your calculator for the coefficients, right? So let's say if I'm doing 4x squared minus 10x squared, what you can enter on the calculator is 4 minus 10, right? Which is going to give you negative 6. You have to remember to include the x squared because that's not going to change.
And then the other one was positive 4x plus.
Which one? This one?
No, how we got 10 right there.
Yeah. So you have 6 plus 4 plus 10.
Plus 4x.
That's right.
Your calculator is not very well.
Make sure.
Then what will happen?
You have to do it in your head.
Okay.
Yeah. Yeah.
That would be the last step, right?
That's it. You're done. Yeah.
So we don't have to put them, group them together?
Nope.
And show that work?
No. Oh. You don't have to. If you want to, if that's something that, so what Sam is asking is, do I have to put them together? So basically, you can do this. So you can write the like terms next to each other. You see what I'm doing? I'm just shuffling things around so like terms are next to each other. So 4x squared, I wrote negative 10x squared next to it. 6x, and I wrote 4x next to it. Negative 3, I wrote plus 6. And then you can add like terms. Okay? That step is not needed. Okay? This step right here is not needed. Okay? You can right away, if you know your things and you know you're pretty confident with what you're doing. Okay? I personally don't write this step because I feel like it's an unnecessary step. But some people think that this is something that they want to see. They want to see the terms like together.
Why? I was trying to.
Do you want me to write it down?
Yes.
Sorry. My apologies. So this technically should go right here before you write the final answer. So your final answer is inside that rectangle. Okay, are we okay with this so far? Now, when you are simplifying algebraic expressions, sometimes you're gonna deal with brackets, right? And brackets, they're basically the jail for your polynomial. Okay? You can't do anything with that polynomial until you release it from that jail, until you remove this bracket. Okay? But there's rules to remove these brackets. You can't just technically, you can't just say, oh, I don't need these brackets, so let's just erase them and then move on. No. There's things that has to happen there. Okay? Anything in front of a bracket will affect everything in it. That being said, you see that negative right here? That affects every term inside the bracket after it. So that negative is going to affect this, this, and this. Okay? Remember the distributive property that I talked about earlier? This is where we're going to use it. Okay? Are we okay so far?
So the negative affects everything after that.
That's right. Everything inside the bracket after it. So it's you're multiplying every term by a negative. Okay? So the first bracket, technically there's nothing that's going to affect it because there's nothing in front of it. So I can remove it with no restrictions. So I can just write 3x squared plus 4y minus 6. But after that, I have to be careful. Negative 10x squared and plus 12y. Okay? Because you remember the rules, negative times a negative is positive, and negative times a positive is negative. Are we okay so far? Okay. Now, after I remove the bracket, I have released my polynomial from the jail, and now I can put like terms together. Okay? So, my like terms are, so what's the like term to 3x squared? Negative 10x squared. Do you guys want me to write that step? Where I put them next to each other?
Yes.
I'm gonna write it one time, only. I will not keep doing it.
What are you doing?
I'm just writing them next to each other. So I'm writing like terms next to each other. Okay? So all what I did is I shuffled them. What's 3x squared minus 10x squared?
Minus 7x squared.
Okay, excellent. 4y plus 12y.
16y.
And negative 6 plus 1.
Minus 5.
Excellent. Am I done? Yes. And there's nothing I can do. Yes.
This one, you have to show that you added the negative number, or can you just go into the final one?
So you want to jump right from here to here? I mean, you can. It's not wrong. The only thing is if you made a mistake, I cannot give you part marks that way. Okay? But if you show me this step and this step, I can look for where you made the mistake and then give you part marks for them. For the one that you did not make mistakes.
But if you wrote it the other way, it's fine too. The way that you teach us that is the right way that you will be using.
Which one?
The one that you circle over there. That.
Yeah. But in this case, what Dale was saying is, can I go from here to here? Right away. So from here to here. You can, right? If your answer is correct, you'll get the full marks. But if your answer is wrong, you're gonna get a 0 because I don't know what you know and what you don't know. Right? Okay? All right. What I'm gonna do right here, right now, is I'm gonna stop. I'm gonna ask you to do the next question by yourself, and then we're gonna take it up.